Hey students, how you doing today? Mr. Elliott here. Really exciting lesson today. It's last one of the year. I've made I think a little under 120 videos throughout this year, and seriously, from the bottom of my heart, I want to thank my students for this year, from 2016, 2017, who've gone on this journey with me. It's been a crazy year. I've had a lot of good input from students and parents, and um, anyway, just thank you very much for for, uh, for being with me on this journey. Let's just get into our last lesson. As I've been talking in class, our last lesson is sine and cosine story problems. And there's two types of problems, I'd say. There's this one like number one, where they give you the equation and you start off by graphing it. And then there's ones like number two here, where, whoa, there's no equation. And on that one, you still graph it first, but then after you graph it, then you figure out the equation and you answer the follow-up questions. Anyway, let's get into number one, when they actually give you the equation. The period. Let's see, the period for part A, we know that to be 2 pi over b, or the period is 2 pi over b. So pi over 6 is the b. Yikes. So period length is 2 pi over b, which is pi over 6. So in this particular case, the period length is 12. Phase shift, whoa, that's kind of confusing. That's just asking for horizontal shift, and in this case, we're going to start at 1. The axis, we have an axis at y equals 6, and while I'm at it, why not just go on to 6 and put in my dotted line now. Amplitude, there's a 4 in front, so 4, and then sketch a complete graph. So I'm going to start at 1, which is right here, and at 1, actually I need to, let me mark up my graph a little bit more. I've got 6 for my axis, but with the amplitude of 4, it's going to max out at 10 and min out at 2. And we're talking a cosine graph, and the period is 12, which means after 1, it's going to repeat itself to 13, and it's a cosine graph. So at 1, I know it's at the top because that's what a cosine graph does. Halfway between, whoa, students can't see that, Elliot. Sorry about that. So my first thought at 1, because of the horizontal shift, the period's 12. So 12 hours later, I'm at 1300 hours, 1 p.m. And those are, it's a cosine graph, so these are both high points. Halfway between this is at 7, and 7 would be a low point. Halfway between 1 and 7 is 4. That would be an axis point. Halfway between 7 and 13 is 10. That would be an axis point. They gave me this much graph paper, so I might as well use it. Let's see, another 6 hours would put me at 19 hours. And I know that after another 6 hours would be at the bottom of the cycle. And in the middle at a 16 would be the axis. And I connect it like it's a cosine graph. Connect the dots, la 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 la. Connect the dots, la 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 la. Alright, and I have that cosine. Start answering some of these questions. Maximum depth of the water. Well, that's just them kind of asking about amplitude. That maximum depth would be 10, how are we measuring this? Feet? 10 feet. Minimum depth of the water would be 2 feet. And anybody who's ever been, spent a little bit of time by the ocean, you know how like middle of the day, the water will be all extra deep, but then like right around sunset, it seems like the water's, it's really low. Sometimes it's 0, or in this case, it's 2 feet. That's exactly what the tide does. When does the first high tide of the day occur? All right, we've got to be careful here. T represents the elapsed time since midnight. So right here at the start of the graph is midnight. First high tide of the day, well, that would be, first time after midnight, which would be 1 a.m. When does the first low tide occur? Low tide is right here at 7 hours, so that would be 7 a.m. After the first high tide occurs, how many hours elapse before the next high tide occurs? Well, that was 12, period length was 12 hours later, 12 hours after 1 a.m. If you're talking military time, you could say 1,300 hours. But if you're just talking normal AM, PM time, 1 p.m. All right. That's it. That's how you go about doing one of these story problems when they give you the equation. You graph it, and then you answer some questions about the graph. All right. Number 2. Second problem, what happens when they don't give you an equation? Well, if they don't give you an equation, you need to draw your own graph. So let's start thinking about this. We have a water wheel. Water's going around in this wheel. There's a radius of 7 feet, and it makes 6 revolutions per minute. Oh, that's confusing. The radius is 7 feet. The center of the water wheel is 6 feet above the surface of the water. So let's draw a little side graph. We got this water here. The water wheel is positioned in a way that the radius is 7 feet, and at this distance it's 6 feet above the water, which means 1 foot of it goes below the water. As the circle, like the circle's going to keep going around and around, and at some point it's going to be 1 foot over the water, but then at other points it's going to be way up here. And if you think about that radius is 7, you got the 6 feet from the underwater to the center, and another 7 feet to the top. So at some point you are 1 foot below the water, so at -1. But then by the time you get up to the top, you're not 14. You're now 13 feet above the water for that 6 and that 7. So my maximum's at 13. My minimum is going to be -1. Halfway between 13 and -1. Let's see, these add up to 12. 12 divided by 2 is 6. So 6 is my axis. So got an axis at 6, maximum at 13, minimum at -1. And when you start your stopwatch, so when time is at 0, starting your stopwatch, is at its lowest possible position. Its lowest possible position is down here at the bottom. Okay, now let's see. 6 revolutions per minute. That means every 10 seconds I get a revolution, or every 1/6 of a minute. So do I want t to be minutes, so I can have each marker, each period be 1/6 of a minute? Or do I want t to be seconds, in which case I'll have it every 10 seconds is a period? Well, using a fraction versus using a whole number, I choose seconds. So t is going to be seconds. And I know after, so if this is at 0, I know after 10 seconds it's going to do 1 whole rotation. So it's going to start at the bottom point, it's going to end at the bottom point. At the midway point, after 5 seconds, it's at its top point of 13. So 2.5 would be this point, and 7.5 would be the other axis point. And I can draw my graph just like this. Whoa! That should be a smooth graph. Let me do that again. There, connect the dots. I wasn't singing this song. I had a hard time connecting the dots. Okay, so let's take a look at this graph here. We need a sinusoidal equation. Now, when it says sinusoidal, I know you might be thinking sine right now, but it could also be cosine. Doesn't really matter. For this equation, I'm going to write both a sine and a cosine equation depending on your mood. I think a cosine graph is going to be a little bit better because that's going to deal with a whole number, whereas if I do a sine graph, it's going to start here, and that's going to be a decimal start point. I don't really like that idea. So I choose cosine. A distance of 6 up to 13, that means that there's an amplitude of 7. So 7, and I chose a cosine. And then the b, let's see, the period length. So period length equals 2 pi over b, and in this case the period length is 10. 2 pi over b, so that means that 10b, if I multiply both sides by b, equals 2 pi, divide by 10, and I get 2 pi over 10, which is equal to pi over 5. So my b is pi over 5 times x minus my start point, which is 5, close, close, plus 6 for that horizontal shift. If you wanted to do a sine graph, you could. It would still be an amplitude of 7, it'd still be a sine. It's still a period length of 10, which means b is still pi over 5. The only difference is the start point is for a sine graph, I'd need to start at this 2.5, so x minus 2.5 plus the same 6. Okay, now what's nice about this, once you have an equation, you can figure out the height of this wheel at any point. If you plug in 2.5, the answer is going to pop out 6. If you plug in 5, what's going to pop out is 13. If you plug in 10, what's going to pop out is -1. In this case, we want to go 25, and I'm going to use this one that has the non-decimal answer. So part B, at 25, I have y equals 7 times cosine of pi over 5 times 25 minus 5 plus 6. All right, y, not 7. Y equals 7 times cosine of 25 minus 5, that's 20. 20 divided by 5, that's 4 times pi, 4 pi plus 6. All right, cosine 4 pi. That is equal to +1, and you know that because cosine of 0 is 1, cosine of 2 pi is 1, which means cosine of 4 pi is 1. They're all coterminal to each other. So I get 7 times 1 plus 6, which ends up being 13. So you know after 25 seconds, you're actually right at the top, and you're at 13 feet above the water. But you could find any height by plugging in any particular number. I'm curious, what would have happened if I would have used the sine equation? I am done with this problem at this point, so if you want to go ahead and wrap it up, you can, but if you want to explore with me what happens with sine, same equation, that'd be fun. So if we plug 25 seconds into the sine equation, I'd get 7 times sine of pi over 5 times 25 minus, pi over 5 times 25 minus 2.5. Close, close, plus 6. This becomes 7 times sine of, side work, do a little side work here, 25 minus 2.5. So I have 22.5 divided by 5 pi. You'd multiply that by 2 over 2, and you'd get 45 pi over 10. 45 pi over 10. Yikes. Let's see. You could pull out 5s out of that, and you'd get 9 pi over 2. Then you'd need to think coterminal. 9 pi over 2 minus 2 pi, so minus 4 pi over 2. That's 5 pi over 2. That still doesn't do it, so I subtract 4 pi over 2 again, and I get pi over 2. So what started off is 22.5 pi over 5 plus 6. We simplified this to 45 pi over 10, which simplified to 9 pi over 2. But then we did coterminal angles, which would mean this would also work for 5 pi over 2, but that's not within unit circles, so we get all in pi over 2. So I have 7 times sine of pi over 2 plus 6. Sine of pi over 2, oops, sine of pi over 2, that's 1. And 7 times 1 plus 6, that's 13. Whoa, you got the exact same answer. But of course that makes sense, because you knew that you did this previous part right. So regardless of which equation you chose to use, you should get the right answer. All right, everybody. Thank you so much for watching some lessons with me this year. I really appreciate it. I'd like to close off this year, I suppose, by playing a smidgen of music for you. This is my jaw harp. I learned on a trip to Long Beach, Washington once how to play. This is actually the first jaw harp I ever bought. You can buy one like this for like $3-4. Super cheap instrument to buy, lifetime to master. If you get good at using the cheap one, the ones that like cheap, like $3, $4, $5, there's ones that cost like $30-40, and those sound so much better. They're a little harder to play. I have a nicer one, but I didn't think to bring it to school today. I just have this cheapy one. So let me play a little jaw harp for you. Enjoy. And I don't have anything else to say, so if you think this is lame, you should go have yourselves a great day, and I'll talk to you later. Thanks, everybody. It's been a fantastic year. I'll talk to you soon. Have a great day. Mr. Elliott out. Bye-bye.